Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be learning all about the electronic expansion valve. We'll look at how they work, where to locate them, and why you should use them. Today's video is brought to you by our partners over at Danfoss who have kindly sponsored this video. Danfoss is committed to providing the very best solutions for a wide range of applications, including chillers, cold rooms, and heat pumps. These solutions include their series of high-quality electronic expansion valves, which are approved for use with all common refrigerants as well as a wide range of capacities and pressure ranges. The compact and durable design make them easy to install while enabling significant energy and cost savings. You can check out their entire range of electronic expansion valves by following the link in the video description below. Electronic expansion valves are used in refrigeration systems to precisely control the flow of refrigerant into the evaporator. You can find these on everything, including VRF units, inverter mini splits, heat pumps, chillers, AHU coils, etc. Now, we've previously covered how thermal expansion valves work. These are very common in refrigeration systems, but they are nowhere near as efficient or precise as an electronic expansion valve. If you haven't watched the video on how these work, then I highly recommend you do so. Links are in the video description below. Electronic expansion valves are an evolution on the thermal expansion valve. They are much more sophisticated and allow the refrigeration system to operate much more accurately and efficiently. You'll usually see the electronic expansion valves listed with the acronym of either EEV or an EXV. They both mean the same thing, it just varies by manufacturer. There are many benefits to using an electronic expansion valve, and I've listed some of the main points on screen now. The focus though is usually that by using an electronic expansion valve, you're going to reduce the energy consumption of the refrigeration system, as well as gaining much better performance. What do electronic expansion valves look like? There are many different designs for an electronic expansion valve, and I've put a few examples on screen now so you can see how their appearance varies. The difference in design depends on the type of system, the refrigerant used, and the pressure it's working with. As you can imagine, a small split AC unit isn't going to need the same valve as a high pressure industrial application, so the design is going to vary. Although, the basic working principle is essentially the same. Main parts of the electronic expansion valve. As we just saw, there are many different designs for electronic expansion valves, but we're going to focus on a simplified design to help build your base knowledge. This design uses a permanent magnet stepper motor. At the head of the valve, we have the stepper motor body, which contains the copper coils. These are used to generate an electromagnetic field, which will be used to control the valve's position. Sitting concentrically within the main body of the stepper motor is a permanent magnet. This permanent magnet is affected by the electromagnetic field of the coils, and the change in polarity of the electromagnetic field will cause the permanent magnet to rotate. Attached to the permanent magnet there's a shaft. Now, some designs will use a gear assembly between the motor and the shaft, but as we're only looking at a simplified example, we're going to stick to a directly coupled shaft. On the shaft is a thread. This thread sits within a holder which is attached to the valve body. At the end of the shaft is a valve needle. Then we have the valve seat, which the needle moves into and out of to close and open the valve and control the flow of refrigerant. We'll also have some temperature and pressure sensors to take measurements of the refrigerant in order to calculate the superheat. These will be connected to the controller. The controller is then connected to the stepper motor and will tell it how much to open or close to maintain the correct superheat. So how does an electronic expansion valve work? If we have a look at a typical refrigeration system, you can see the main parts being the evaporator, the compressor, the condenser, and the expansion valve. The evaporator collects all the unwanted heat from the building and transfers this into the refrigerant, which causes the refrigerant to boil and evaporate. The compressor then sucks in this evaporated refrigerant, which is a low pressure, low temperature, and slightly superheated vapor. It then compresses this into a smaller volume, which causes it to be a high pressure, high temperature, superheated vapor. The refrigerant then moves to the condenser, where the unwanted heat is pulled out of the refrigerant and rejected into the atmosphere. This causes the refrigerant to condense into a liquid, so when it leaves the condenser, it will be a high pressure, medium temperature, saturated liquid. It then passes down into the expansion valve. The expansion valve causes a pressure difference between the condenser and the evaporator. It holds back the high pressure liquid refrigerant and decides how much to let through into the evaporator. As the high pressure liquid refrigerant bursts through the small gap between the valve seat and the needle, it drops in pressure. This will result in some of the refrigerant vaporizing, and the rest will continue through as a liquid. If you want to visualize this, it's similar to a water bottle spray nozzle. As you pull the trigger, the high pressure liquid is forced through a small orifice into a much lower pressure atmosphere, which causes the water to become part liquid and part vapor. This mixture of liquid vapor refrigerant is sprayed into the evaporator where it will absorb heat from the air or water which surrounds the outside of the pipe, which forms the evaporator coil. In this case, we have a fan which is blowing air across the evaporator coil. As the refrigerant passes through the evaporator coil, it is exposed to thermal energy which will cause it to undergo a complete phase change from a liquid to a saturated vapor, still at a low pressure and temperature.